Look at this image. From the silence of space, Earth appears as a perfectly balanced haven, wrapped in bright white clouds and deep blue oceans. We think of this environment as permanent, but that stillness masks a history of extreme instability. If we rewind the clock 4.6 billion years, the water and land we rely on disappear. The planet itself vanishes. In its place was a disorganized cloud of golden gas and stardust, the scattered debris left over from the birth of our sun. This peaceful world was forged in a billions of years-long demolition derby. The architect of this chaos was gravity, which began acting on that scattered cloud of stardust, the Solar Nebula. This simulation shows gravity's pull forcing the massive cloud to collapse and flatten into a dense, rapidly spinning disk. Within that disk, tiny grains of minerals began crashing into one another, binding together to form pebbles. Over millions of years, this snowball effect escalated. Pebbles merged into giant boulders, which collided to build massive planetoids. These millions of high-speed collisions generated immense kinetic energy, which transformed into heat. This relentless gathering of material birthed a hostile, boiling ball of liquid rock, baking at over 2,000 degrees. This was the young Earth, a volatile, molten target in a crowded, violent, and unstable early solar system. A Mars-sized planet named Theia was pulled into this orbit, locking on to a direct collision course. Astronomers call the result the Big Thwack. Theia slammed into the young Earth with enough force to nearly obliterate both planets, ejecting a massive wave of molten debris into space. The surviving core of Earth used its gravitational pull to capture that debris before it could drift away. That superheated rock formed a chaotic ring orbiting our planet, eventually clumping together to form our moon. This catastrophic impact created the satellite that would later exert the gravitational influence required to anchor Earth's tilt and drive the rhythm of its tides. As the solar system matured, the constant barrage of massive rock collisions finally began to slow. With fewer impacts generating heat, Earth's surface finally cooled enough to harden into a rocky crust. This diagram illustrates the atmospheric reaction to that cooling. Water vapor that had been trapped as superheated steam finally reached its condensation point. The sky opened, and torrential rain fell without interruption for thousands of years. That endless downpour pooled in the basins and craters of the crust, filling them to form Earth's first primitive oceans. The extreme heat of formation, followed by this cooling phase, provided the specific thermodynamic conditions required for Earth to capture and hold liquid water. Eventually, the steam cleared and the rain stopped, revealing the planet transformed from a landscape of harsh reds and grays into vibrant blues. This timeline traces the exact sequence. A nebula collapsed into a spinning disk. Molten accretion drove temperatures to the extreme. A planetary impact forged a moon, and a final drop in temperature triggered the Great Rain. Every calm ocean breeze and moonlit night we experience today is a direct result of these violent planetary collisions and a 2,000-degree inferno. The life-sustaining blue marble we call home was forged entirely through cosmic chaos.